Lesson 2, Isosceles and Equilateral Triangles. Our objective, I can apply theorems about isosceles and equilateral triangles to solve problems. So let's recall. Remember that an isosceles triangle has two congruent sides, and then the angles opposite to those sides are going to be equal. In an equilateral triangle, all the sides are congruent, therefore all the angles are also congruent. Now it says to cut out the triangles with two sides. Just skip that part and go straight on to the second part. Just trace the outline of the triangle onto a patty paper. So use patty paper for that section. And then label the angles. In how many different ways can you flip, slide, or turn the triangle so that it fits exactly onto the outline? You can do a vertical reflection. And of course, you can do a translation. How do the angles and sides of the outline correspond to the angles and sides of the triangle? When it's a translation, they're all basically the same way. But when you do a reflection, we can see that angle 2 and angle 3 are going to be congruent, as well as angle 2 and 3 on the other side. So basically they're just swapped. The locations of angles 2 and 3 are swapped. How would you answer part A, or how would your answer to part A change if all three sides of the triangle would be the same? Well, in this case, we would have also rotational symmetry. And that would be at 120 degrees, and it would also have rotational symmetry at 240. Since it has that rotational symmetry, it would also have reflectional symmetry. Will this process work with any other triangle? No. Not all triangles have rotational and reflectional symmetry. With this isosceles triangle, I know that the sides are going to be congruent and the opposite angles would be congruent. If I were to bisect the angle that is not congruent, it would also bisect the side opposite that's not congruent, creating a perpendicular bisector. So that would form a 90-degree angle, bisecting this segment in half, and it would also bisect the angle into two congruent angles. So we end up with two right triangles that are congruent. Okay, so we can see that this line segment is actually going to be the perpendicular and angle bisector. So it is cutting my triangle into two equal parts, and it has that reflectional symmetry. And it's asking for what other rigid motion will map this onto, would map angle A onto angle C. And we can do a rotation. Go ahead and use patty paper and figure out how many degrees I would have to rotate this in order for angle A to be on angle C. With the reflectional symmetry, we know that once we reflect it, angle A would map onto angle C, If we want to perform other rigid motion that would map this, we can also do, there's different combinations, but we can do a rotation centered at B, and we can do a 180-degree rotation of this triangle. That would leave this triangle inverted. And then from here, do a vertical reflection. And once again, angle A would overlap to angle C. The Isosceles Theorem. The Isosceles Theorem states that if side A is congruent to side AB is congruent to side BC, then angle A would be congruent to angle C. And the converse is also true. So if angle A is congruent to angle C, that means that side AB is going to be congruent to side BC. We're going to be using this theorem to find the values of x. So let's go back to what we know. I already know that these two angles are going to be the same, so that means that the base angles would be the same. If that angle is 28, this angle would be 28. And using the triangle sum theorem, I know that all the angles inside of a triangle add up to 180. So we're going to create an equation combining both of these theorems. Go ahead and solve for x. Okay, so we see that x is equal to 23. Going on to example B, they're telling me that these two sides are congruent, and I know that the base angles are congruent. So in this case, my equation would show that both of these angles are congruent. So segment, or this measurement, negative 4x plus 9, is going to be equal to 8x minus 3. Go ahead and solve for x. So here we end up with x is equal to 1. In these examples, we're going to be using the converse. So I know that if the base angles are congruent, then the opposite sides are going to be congruent. So my first equation would be 8x minus 1 is going to be equal to 4x plus 9. The problem is only asking me to find the value of x, so I'm not going to need this piece of information. Go ahead and solve for x. Okay, so once we follow inverse operations, we end up with x is equal to 1.5. For part B, it's asking me to find the length of all three sides. We already have our value of x, so we're going to use our value of x and just substitute it into each one of these segments. So the first side is 8x minus 1. We're just going to substitute 1.5 in place of x, and we will have that angle measurement. You're doing the same thing for the other two sides. Okay, so we end up with 11, 11, and 14. If you were copying what I had done minus 5 here first, but it's plus 5, so hopefully you copied it right. Okay, in this case, you're going to be using the theorem for perpendicular bisector. This is theorem 4-2, and it's on page 161. 161 in your textbook, so you guys can go ahead and copy that theorem down. What is the measurement of angle RSQ? So we need to find this measurement. I know that the base angles are going to be congruent. I know that that's 4. So this piece is also going to be 4 because this is our perpendicular bisector. It's cutting the triangle. It's cutting that base angle in half, and it's forming 90-degree angles. This will also be 31 degrees. This would also be 4. So knowing that this is 90, if I just need to find this angle measurement, I know that the angles inside of a triangle add up to 180. So it would be 31 degrees plus the angle that I don't know, plus 90 is going to give me 180. To solve for the measurement of angle RSQ, I'm using x in place of that. Combine your like terms, and you're going to have that x degrees. 90 plus 31 gives me 121, and that's equal to 180. Take away 121 from both sides, and we end up with x is equal to 59 degrees. So that means that the measurement of angle RSQ is equal to 59 degrees. What is the measurement of side PR? And PR is this whole segment. Like we notice, I know that this is segment bisector, perpendicular bisector. So if that's 4, this is 4. That means that segment PR is going to be equal to 4 plus 4, which is 8. How do you know that an isosceles triangle can be decomposed into two congruent right triangles? Well, we know that if the triangle is isosceles, these sides will be congruent and the base angles will be congruent. If we construct that perpendicular bisector, it's going to cut the base in half and it will cut the angle in half. So that perpendicular bisector basically becomes a line of symmetry. We can reflect this right triangle using the line of symmetry. And we see that one of the triangles overlaps the other. And if there's a series of rigid motions that maps one onto the other, we know that the triangles would be congruent. And since this is a perpendicular bisector, I forgot to say that. This is going to form 90-degree angles. So remember that line of symmetry, that's your perpendicular bisector, forming those 90-degree angles on the base, cutting the base in half, and we know that a reflection is a rigid motion, so therefore these two triangles are going to end up being congruent.